so far, our idea of force is only a dynamical one. That is, we watch an object, we look to see, is its motion uniform? Does it move at constant momentum? If not, what's true? We say, there must be a force that is acting on it, and the degree to which its momentum is changing is the force. But if you think about force, you don't have that as a visceral sensation. How would you define force? Let me put it another way. Exert a force on whoever is sitting next to you. I knew it. Okay, so
I couldn't even need to do it. I could have just sat here.
and now I'm going to get sued for harassment. Yeah, okay. Well.
I know.
Okay, so I need a bit of help. I need a couple of volunteers up here. There's one. There's one. Okay. So this is 21st century technology here. Yeah, sure. Okay. So what we're going to do is interrogate this spring by adding successively a bunch of these masses, and one of you is going to add them, and the other is going to read out where this thing is. And I should be able to bop the numbers in, allegedly, if I can remember how to do this. Okay, so wait for it. We got to... turn on mirroring. And, okay, so before edit. Yeah, okay. So where is it before you add anything?
Like 47.5 centimeters.
Okay, so 47.5 centimeters is the y. So this is going to be 0. 47. Okay, go ahead. I think they're 20 grams each, so we'll put on 20. Take an average.
Like 49.5.
Okay, keep going.
Okay. 40 grams. It's gonna tilt.
Watch it all fall to the ground.
It's like 51.7, I think? Yeah, 51.7.
Okay, doing a heck of a job. I should wipe these.
That's like 55.8.
How much?
55.8.
55.8. Do you get the pattern yet?
No.
One more, one more.
57.6.
It looks parabolic.
You look parabolic.
Whatever that means. Shots fired, Zach.
That's almost a perfect line.
Somebody do a regression.
Nobody do a regression. All right.
Open Igor.
Trust me, I almost did. We'll get to that later. Thank you very much. We have a property of springs. Okay, let's see if I can get back going again. Mirroring off and go. So it is springtime. Okay. Excellent.
Is that Nicolas Cage?
His father. Notice this came from the Spanish version of Wikipedia, okay? I don't play favorites. So this is Robert Hooke. Robert Hooke was a contemporary of Isaac Newton and somebody that Isaac Newton despised. And Robert Hooke, in investigating springs, figured out something that was very, he thought, significant. And when you have something significant, you want to publish. But he decided the best way to publish this information was in a Latin cryptogram. So we will take and publish to the world that mess. And challenge. Now, the fact that it was in Latin was normal because Latin was the lingua franca of science in Europe at the time. But when unscrambled, it really was supposed to be tensio vis, if you pronounce Latin with a w sound for the letter w. Okay, so translated, it is as the extension, so the force, so a Hooke's law spring satisfies this, that the spring force, the spring will exert has a magnitude that is proportional to its elongation away from an equilibrium position. Okay, simplest possible thing, it's linear. And the spring constant, K, tells you for each a little additional amount of elongation how much more force the spring will supply. Okay?